Hi, today I will talk about my graphic model project about the exact inference and the approximate inference. The goal is to compute the log partition function zset. The figure 1 shows the structure of how I save the Markov file. I defined a class called factor to store a variable which forms a clique and the corresponding partition table. Figure 2 shows the structure of a junction tree. The difference is that the factor of a junction tree is max clique. And the first step of the exact inference is to transfer a graph G into a triangulated graph. There are a number of heuristics to find a good elimination order, such as mean fill-in heuristic, mean size heuristic, mean weight heuristic. I choose mean fill-in heuristic in my project. The idea is that to eliminate node n, which would result in the smallest number of fill-in edges. Here is the pseudocode. Then we need to find max clicks. When we running the elimination algorithm, all max clicks in the resulting reconstituted graph are encountered. So every elimination click must be a max click or a subset of some previously encountered max click. This is how I find all max clicks. Then we need to build a junction tree. A tree of maximal clicks T is a junction tree if and only if it is a maximal spanning tree on the maximum clicks graph. The edge weight equals to the cardinality of the separator between the two maximal clicks. I use Prince algorithm to find the maximum spanning tree. First, we need to initialize the edge set and reach the node set. Here is the root of the junction tree. Then we iteratively choose the largest cost edge, uv, such that u is a reached node and v is not a reached node. Then we add uv into edge set and add v into reached node set. Then we define a message passing protocol. A message may be sent from node I to a label node j only when node I has received a message from all its other neighbors besides j. Since we only need to compute z, this can be simply done by performing a post-order traversal on a junction tree. This is a pseudocode. Then we can calculate z by summing up all the potentials in the root max click. Those are for exact inference. For approximate inference, we use NUPI belief propagation. This is a formulation of a generic message. We use fact graph. The left side here is variable and the right side here is all factors. Define a form of belief propagation or a fact graph, going back and forth between the left and right nodes until the message converge. Then we use beta approximate to calculate log z. Here is a formulation of beta entropy approximation. H here is a singleton entropy, and I here is a mutual information. So this is the experiment result of my code. You can see here, for Markov 7, it takes hours to run the exact inference, but it only takes half a minute to run the approximate inference, and we can get a similar result. So the conclusion is that for model which has a smaller max click size, the running time of exact inference will be close to the approximate inference, even faster. But for model which has large maximum click size, such as 29 or bigger, the approximate inference will be more feasible and effective. So that's all for my presentation. Thank you for listening.